Alright, welcome. This is the 6.5 Ready, Set, Go homework solutions. Alright, the ready part. Just some polynomials, some definitions and names. First one. What is a polynomial? Describe it in your own words. Polynomial, it's a two-dimensional object, okay, which is on a plane. That's formed with straight lines. Okay, there's regular polynomials and irregular polynomials based on the symmetry. Okay. Fill in the names of each polynomial based on the number of sides the polygon has. 3, we know that as a triangle. 4 is a square. 4 is also called rectangle. 4 is also called quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a hemp. 8 is oct. 9 is non. And 10 is decagon, right? For any n-gon, it has n sides, okay? Do you need to remember these words? You should, okay? The number of sides here as well. Alright, so next, let's look at the set part. Alright, one quadrilateral with special attributes is called kite. Find the geometric definition of a kite and write down with a sketch. Here's a kite. Okay, we have these two are similar, right? One hash red. Here are two hash, right? This means these two are congruent, right? So these are congruent and these two are congruent. A kite is a quadrilateral, four sides. Two pair of consecutive congruent sides, but opposite sides are not congruent. Okay, these two, right, are congruent. These two are congruent. These two are not congruent. Okay, that's what they mean. Opposite sides here are not congruent. Alright, next, draw a kite and all the lines of symmetry and its diagonal. Okay, here we see that this is a kite. Okay, a kite has one line of symmetry. It goes straight down. Or, right here, if I draw it to the side, it goes left to right from B to D. Okay, we say that right here, that AC, the line AC, is perpendicular to BD. BD would be the line of symmetry. List all the rotation and symmetry for a kite. So we know that a kite has one rotational symmetry, which is 360. Let me show it to you. Watch this. Okay, right now it is at 0 degrees. Okay, sorry. Okay, right, exactly the way it is. Right, this is at 90. Okay, 180. Right, 270 roughly, and it finally goes back to where it is when it is 360. Okay, that's why its rotational symmetry for this one would be 360. There you go. Number 6, are lines of symmetry also diagonals in polynomial? No. Right, do you see here that the diagonals are the orange, which are not the same as the lines of symmetry, which is the purple and the orange, because a square has 4 lines of symmetry. Okay, and another 6. Okay, are all diagonals also lines of symmetry in a polygon? Okay, here I have the lines of symmetry, and these are the diagonals for a pentagon. Okay, so this pentagon, we would say that the diagonals are not the line of symmetry. Here it's 1, 2, 3, 4, 5. Right, people think this also has 5 diagonal lines, okay, which is true, but they're not the same values. So not all lines of symmetry are also the diagonals. Okay, here this is just a special case. Right, which quadrilateral have diagonals that are not lines of symmetry? Name some and draw some. Right, here's the rectangle. This is a diagonal, which is not one of the line of symmetry for rectangle. Same thing for parallelogram. Same thing for the kite. We did that from above. And this is a regular trapezoid. Okay, also irregular trapezoid works as well. There's different ones. Okay, 9, do parallelograms have diagonals that are lines of symmetry? If so, draw them. Okay, we already know that's the square. That diagonal is part of the 2 that makes up the 4 for this square. Here's the rhombus as well, rectangle, and parallelogram. Okay, so we can note that sometimes a rectangle and so notice, rectangle, square, rhombuses are parallelograms. A square and a rhombus do have diagonals that are lines of symmetry. Rectangles and parallelograms do not. their diagonals do not make their line of symmetry. Okay, you could just fold a piece of paper if you would like to see that. Alright, let's look at, I think, the go part now. Alright, this is equation of a line, not rotation. Okay, alright, we have this equation, y equals 4x plus 1. The slope here is 4, right? It is the value or the constant, or no, sorry, it is the coefficient in front of the variable, in front of the x. It's just that number, which is 4. The first part, find the equation of the line that is parallel. We know that parallel lines, their slopes are congruent. So, if the slope here is 4, the perpendicular line will also have a slope of 4. Okay, here's the point, 0, negative 7. We know that the y-intercept is negative 7. Okay, plug into the equation, y equals mx plus b. M is 4, again, because m is parallel. And the y-intercept we get from the point here is as negative 7. Same thing here for perpendicular line, but notice, for it to be perpendicular, the slopes here has to be opposite reciprocal. This is 4, this is 1 over 4, the positive becomes a negative. Again, perpendicular means the slopes are opposite reciprocal. So if you want to plug into your equation, right, the equation would look like something like this. Okay. Grab the new slope, perpendicular slope, plug it in here. The y-intercept remains the same as negative 7. There you go. That would be your perpendicular line. That would be your parallel line. Here we have the table. So from the table we should compute the slope, which is negative 2. That's also called the rate of change. Right? Again, here we have the point, negative 8, 8. That means the y-intercept here is 8. Okay? Slope here is negative 2. If it is parallel, the slope here are congruent, are the same. So the equation is y equals negative 2 because, again, the slopes are the same. X plus 8. Where do I get the y-intercept? Come here from the point. Next, perpendicular line. So the slope is perpendicular, so it becomes 1/2. Then the negative becomes a positive. So the perpendicular slope is 1/2. The equation is y equals 1/2 x plus 8. Next, we have the equation of a line. From the line, we should get the slope. It's negative 1 over 3. How do I get negative 1 over 3? Look, it goes down 3. It goes down 1 across 3, right? Okay, horizontal, right? Change of vertically divided by the change horizontally. Negative 1 over 3. Okay, so find the equation of line parallel to the given information through the indicated y-intercept. Again, parallel means same slope. So y equals negative 1/3 x minus 3. How do I get the negative 9? The negative 9 goes here. Where do I get the negative 1/3? The negative 1/3 goes there. Next, same thing here, but it is for the perpendicular slope, so it is the opposite reciprocal. So the slope, perpendicular slope, is 3. Plugging it in, you get y equals 3x minus 3. Where do I get the negative 9? Again, that is your slope, your y-intercept right there. So there you go. That was just a little review. If you want like more explanation on this part, you have to go watch an older video. I kind of went through quick about this, okay? But important things, right? You have to understand the diagonals, properties of the kite, and the basic ideas of the polynomials, okay? Polygons, all right? There you go. Those are all your solutions for 6.5.